This is the summary created from the video. Lecture 49 Docker Container Demo. In the realm of AC microgrids, parallel operation of inverters enables increased renewable capacity while providing scalability by simply adding more inverters instead of a single large unit. However, this parallel setup presents challenges as the inverters exhibit interactive currents that oscillate between them at the filter, resonance frequency, and common currents that deliver renewable power to the grid. Through detailed mathematical modeling, the interactive currents are shown to depend on the plant transfer function and reference current differences, while the common currents rely on the grid impedance and sum of reference currents. To demonstrate these principles, a test bed has been constructed with two inverters connected to a grid emulator through LCL filters, with separate DC sources and grid impedances. In the first test case, when both inverters have equal 5A reference currents, no interactive current flows between them, leading to stable waveforms of the PCC voltage, combined current, and individual currents. However, in the second test case, with intentionally unequal reference currents of 5A and 6A, oscillatory interactive currents are observed due to the reference current difference, causing high-frequency oscillations in the individual currents at the resonant frequency of the LCL filters. In summary, parallel inverter operation offers scalable renewable capacity, but requires careful consideration of interactive and common currents, which can be modeled mathematically and validated through hardware demonstrations, showcasing the importance of equal reference currents for stable operation. Please stay tuned for more summary videos.